Let's see if we can find some trig identities for the sine, cosine, and tangent of the difference between two angles, which we'll call A and B. So we want to write the sine, cosine, and tangent of A minus B in terms of these expressions over here. To figure these out, you'll first need to know the trig identities for negative angles. So how do the sine, cosine, and tangent of negative angles relate to the sine, cosine, and tangent of positive angles? For each of these identities, fill in the missing coefficient, which is either 1 or minus 1. And if you'd like to review these identities instead, then click down here. Right, it's a minus 1 here, a plus 1 here, and another minus 1 down here. So here are the negative trig identities. Let's hold on to them up here. Next, do you remember the identity for the sine of A plus B? Right, and this identity is true for any angles A and B. It even works if we replace B with negative B. So let's also make the b's negative on the right side. Now A plus negative B is the same as A minus B. Let's see if we can simplify this expression a little. Notice the cosine of minus B over here. According to the negative identity for cosine, cosine of minus B equals the cosine of positive B. Also, the sine of negative b equals the negative sine of positive b. So we can pull the minus sign out of the sine function. And now we have the trig identity for the sine of A minus B. For any angles A and B, the sine of A minus B equals sine A cosine B minus sine B cosine A. Let's look at the cosine next. What's the identity for the cosine of A plus B? Right. Once again, let's replace all the b's with negative b's. On the left, A plus negative b is the same thing as A minus b. If we look at the cosine of minus b term, this trig identity up here says that it's equal to the cosine of positive b, so we can ignore this minus sign. And if we look at the sine of negative b, it's equal to the negative sine of positive b, which means we can pull the minus sign out of the sine function. And because we're pulling out the minus sign onto another minus sign, we get a plus sign. And here's another trig identity. For any angles A and B, the cosine of A minus B equals cosine A cosine B plus sine A sine B. Finally, let's move on to the tangent function. Here's the addition identity for tangent. Try using this formula along with the negative identity for the tangent function to find the identity for the tangent of A minus B. Which of these is the correct identity? If you're not sure, just click here. Nicely done. For any angles A and B, the tangent of A minus B equals tan A minus tan B over 1 plus tan A tan B. Let's see if we can find some trig identities for the sine, cosine, and tangent of twice an angle. So we want to write the sine, cosine, and tangent of 2A in terms of the sine, cosine, and tangent of A. But before we get started, do you remember what the identity is for the sine of A plus B? If you'd like to review this identity instead, then click down here. Right, the sine of A plus B equals sine A cosine B plus sine B cosine A. Now this identity works for any angles A and B. It even works when the two angles are the same. So let's make them the same by setting B equal to A. That means we can replace all the b's with a's. On the left, we now have the sine of A plus A. A plus A is 2A, so we have the sine of 2A. And it's equal to sine A cosine A plus another sine A cosine A. Adding these two terms together gives us 2 sine A cosine A. And that's the trig identity for the sine of 2A. For any angle A, the sine of 2A equals 2 sine A cosine A. Next, let's figure out an identity for the cosine of 2A, and we'll start with the cosine of A plus B. Which of these is the correct identity? Again, if you're not sure, click down here. Right, the cosine of A plus B equals cosine A cosine B minus sine A sine B. Once again, this identity works for any angles A and B, even if they're the same. So let's set B equal to A, and replace all the b's with a's. On the left side we have cosine of 2A, And on the right side, cosine A times another cosine A is cosine squared A. Just so you know, this expression here means you're taking the cosine of A and then squaring the cosine. When trig functions are raised to powers, you'll often see the power between the trig function and the angle that goes into it. And over here, sine A times another sine A is the square of the sine of A, which can be written and read aloud as the sine squared of A. And that's our second double angle identity. For any angle A, the cosine of 2A equals cosine squared A minus sine squared A. Finally, let's find an identity for the tangent of 2A. Here's the identity for the tangent of A plus B. Try using this to figure out which of these expressions down here is equal to the tangent of 2A. Nicely done. The tangent of 2A equals 2 tan A over 1 minus tan squared A. So here are your double angle identities, and they're true for any angle. Let's see if we can find some trig identities for the sine, cosine, and tangent of 3 times an angle. So we want to write the sine, cosine, and tangent of 3A in terms of the sine, cosine, and tangent of A. Now to do this, we'll be using the addition identities. So first off, do you remember which of these expressions is equal to the sine of A plus B? If you'd like to review the addition identities instead, then click down here. Right. Now this identity works for any angles A and B, including the specific case when B is twice the size of A. So let's plug in 2A for B. And let's do that for every B in this identity. On the left side, we have A plus 2A inside the sine function, so that's 3A. And on the right side, we have these two terms, which we can simplify using the double angle identities. First, let's look at the cosine of 2A. Which of these expressions does the cosine of 2A always equal? If you'd like to review the double angle identities instead, then click here. Great, so let's plug this expression in for the cosine of 2A. Next, let's look at the sine 2A term down here. Which of these expressions does the sine of 2A always equal? Right, so let's plug this expression in for the sine of 2A. Now in this top expression, we can distribute the sine of A into this difference, and that gives us sine A times cosine squared A minus sine A times sine squared A, which is sine cubed A. And for this expression down here, cosine A times another cosine A equals cosine squared A. So that's our identity for the sine of 3A, but we can still combine two of these terms. Sine A cosine squared A plus another 2 sine A cosine squared A gives us 3 sine A cosine squared A. So for any angle A, the sine of 3A equals 3 sine A cosine squared A minus sine cubed A. Now let's find the triple angle identity for cosine. First, what's the identity for the cosine of A plus B? Okay, so that's the cosine of A plus B. Now take a shot at figuring out an identity for the cosine of 3A. If you want to go through it step by step, then click here. Excellent work! So that's the triple angle identity for cosine. For any angle A, cosine 3A equals cosine cubed A minus 3 sine squared A cosine A. So that leaves us with finding the tangent of 3A. Do you want to figure out this identity, or should we just skip ahead to the answer? Okay, let's do this. Tangent equals sine over cosine, so the tangent of 3A equals the sine of 3A over the cosine of 3A. The sine of 3A equals this expression, and the cosine of 3A equals this expression. We could stop here, but for the triple angle identity for tangent, you'll usually see the numerator and denominator both written in terms of the tangent function. So what can you divide the numerator and denominator by so that they're both in terms of the tangent function? Nicely done. So let's divide the numerator and denominator by cosine cubed A. In the numerator, dividing this difference by cosine cubed A is the same as dividing each term by cosine cubed A and then taking the difference. And the same goes for the denominator. So now we'll go through each of these fractions and simplify. First, let's tackle this fraction up here. How can you rewrite it using the tangent function? Right, this is 3 tan A. Next, how can you rewrite this fraction in terms of the tangent of A? Right, this is the same as tan cubed of A. And what's this fraction down here equal to? Exactly, it's 1. Last fraction. How can you rewrite this one in terms of tan A? Right, it's 3 tan squared A. And that's the triple angle identity for tangent. For any angle A, the tangent of 3A always equals 3 tan A minus tan cubed A over 1 minus 3 tan squared A. So there you have it, the triple angle identities.